Hi students, let us now solve question number 24. It says an air chamber, this is an air chamber of volume V, has a neck of area of cross section A. So this is the area of cross section, and into which a ball of mass small m just fits and can move up and down without friction. So there is no friction here, which is important if you want the motion to be simple harmonic motion. If the ball is pressed down a little, it executes simple harmonic motion with a time period equals to how much? And they are asking us to assume pressure volume variations of this air to be isothermal. So isothermal. So now, see, the main idea is still the same. Right now it is in equilibrium, so pressure outside and pressure inside are same. So the force from here and the force from here are equal. The mass of this is has to be mentioned that it is negligible while considering the forces. Otherwise, even the mg force will act on this. Okay. Even if we consider that force, it will be a constant force. So we are only worried about what happens when you displace this slightly by a distance x, then what would be the restoring force which brings it back. Okay, so in equilibrium some forces here is balanced by some force here, right? But the moment you push this ball slightly down, this volume will decrease. Now if the volume decreases, by how much the volume will decrease? Let's say dv is the decrease in the volume, so that will be equals to the area. So this ball has fallen down here, so the height has decreased by x, area is a, so the decrease in volume will be area into x, right, in magnitude. Okay, now if the volume decreases and the process is isothermal, it means the pressure should increase. So now the pressure from the air here will be more than here. So there will be a net force upward. So the pressure change, to find the change in the pressure, what shall we do? So if you see, they have mentioned the bulk modulus of air to be B. So that is the clue. Now you have to check how is bulk modulus defined. Bulk modulus for isothermal process is minus P. So this we have done in thermodynamics chapter. Okay. So bulk modulus is minus P, and definition of bulk modulus is minus volumetric stress dP by volumetric strain, which is dV by V, so that V will go up. Bulk modulus is just pressure, okay, in isothermal process. In adiabatic process, it was gamma times P, okay. So from here, we can find the change in the pressure. That will be P into dV by V minus. So this is the increase in the pressure due to the volume decrease, which is A into X. So the force which is due to this increase in pressure will be the increase in the pressure into the area. So this is the restoring force which will bring it back, right? Now increase in the pressure is minus P into dV. dV is A into X. So this quantity is A into X. So A into X divided by V into A. So that will become A square. So this is the restoring force. So you can see this is a constant. You should remember that when we write this formula for bulk modulus, dP is the change in the pressure, dV is the change in the volume, infinitesimal change, and V and P are the initial volume and the initial pressure. The initial pressure must be the atmospheric pressure, whatever was outside, and initial volume is mentioned as V. So if this is the force, acceleration will be what? Force by mass. So that will be equal to PA square by mv minus x. So So that would be the acceleration. So from here you can see acceleration is minus some constant displacement. So clearly this quantity will be the square of angular frequency. So finally, what will be the angular frequency? Omega equals to root over PA square by MV. And in the answer, it is given in terms of bulk modulus. So you can replace P by B. So you can replace this P by B. So that will be the answer. So let's see which option it is. So this is omega. Time period will be 2 pi divided by omega, right? So it will be 2 pi divided 2 pi into root over reciprocal of this. So mv by dA square. That matches with option B, right? Okay. Next question is similar to this, but the process is adiabatic. So in adiabatic process, what is the relation for bulk modulus? So in adiabatic process, bulk modulus is given by gamma times P. For this, you have to revise the chapter in the thermodynamic chapter. Okay. So let us see the next question. It's question number 25. Okay. So an ideal gas is enclosed in a horizontal cylinder of area of cross section A. So there is a horizontal cylinder like this. Area of cross section is A, and there is a piston whose mass is M. Frictionless again. Okay. So no friction, so that the motion can be simple harmonic motion without any damping. Okay. So there is some air inside, ideal gas it is, and the piston is in equilibrium with atmospheric pressure. So outside is P naught, piston is in equilibrium, so the force from the outside pressure will be how much? P naught into A. So from here also it should be P naught into A. So this pressure is also P naught. So both the forces will be balanced and the piston will be in equilibrium. Since it is horizontal cylinder, energy will have no role. Okay. Now the volume of the gas right now is V. So now the cylinder is slightly displaced from its equilibrium position and released. What would be the period of oscillation? They are asking us to assume the system is completely isolated from the surrounding. So if the system is completely isolated from the surrounding, it means no heat can come inside or go outside. So it must be adiabatic process. Okay. So suppose I take the piston, let's say slightly this side by a distance x. A small distance x, then what will happen? Volume will decrease. So even in this case, pressure will increase because in adiabatic process, how is pressure and volume related? PV power gamma is constant, right? So when you bring the piston towards the left, volume will decrease. So pressure must increase to keep this constant. Atmospheric pressure will remain same only, but pressure of the gas will increase. So the force from here will be now more than the force from here. So the excess force, which will be your restoring force, that will be the excess pressure into area. Okay. So to find this excess pressure, we will play the same trick that we did before. Bulk modulus now is gamma times P. Okay. Be careful, it is adiabatic process. And definition of bulk modulus is what? Minus volumetric stress is dP. Volumetric strain is dV divided by V. Okay. So from here, the restoring force will be dP if you cross multiply. Gamma P, okay, divided by V into dV. That will be your minus sign. If I write here, it will be dP. So dP will be minus gamma P by V dV into A. Now what will be dV? Like in the previous problem, dV will be the decrease in the volume here. So area is A, so this is the decrease in the volume, right? So area is A, this distance is x. So the change in the volume is area into x in the magnitude, okay? So if you substitute area into x, this A into A will become A square into x. So then if you divide by mass, let me do here itself, that will be your acceleration. and therefore this quantity will be your omega square. So omega will be root of gamma p a square by Vm. Okay, Vm. And time period will be 2 pi divided by this means root over this Vm will go up divided by gamma p a square. Now, when we write this formula, as I told before, this V is the initial volume and this P is the initial pressure. Initial pressure was same as atmospheric pressure. So this P is nothing but P naught. So in the question they have given P naught, but in the options it is mentioned as P. So either we have to write both as P naught and P naught or both as P and P. Okay, either way, the right option will be what? Gamma P A square, option A. Okay, so this completes the oscillation chapter questions which are present in NEET section. Next we will be doing JE level.